Hi everyone, my name is Marcella and I'm an animal science major from the class of 2018.
And my name is Ashley and I'm a bio major from the class of 2019.
Today we will be discussing Chapter 13.3, Problem 7, on page 126 of the workbook. The reaction of carbon monoxide and diiodine pentoxide is endothermic as represented by the following equation. 5 moles of carbon monoxide reacts with 1 mole of diiodine pentoxide to form 1 mole of iodine and 5 moles of carbon dioxide. Note that all reactants and products are in the gaseous phase. How would the yield change from each of the following? A. Increasing the pressure. B. Decreasing the pressure. C. Increasing the temperature. D. Decreasing the temperature. Or E. Decreasing the volume of the reaction vessel.
To answer this question, we first need to talk about equilibrium. As you may have already learned, reactions proceed in both directions. A system is said to be at equilibrium when both the forward and reverse reactions are occurring at an equal rate. We can tell the reaction is at equilibrium when the reaction quotient, Q, is equal to the equilibrium constant K. One important thing to note is that K is constant and tells the ratio of products to reactants. Q, on the other hand, varies depending on where the reaction is in equilibrium. Since K is constant, it doesn't change. However, we can disturb a system that is at equilibrium by adding stress to alter Q. This changes the rate at which the reactions are occurring, which is useful to a chemist who wants to manipulate the relative amounts of reactants and products. We can add stress to a system involving gases, like this one, by changing pressure, temperature, or volume of the reaction vessel. So how do these changes affect our yield? Le Chatelier's principle says, when stress is added, the reaction will shift one way to re-establish equilibrium, and K equals Q. If K is greater than Q, then the forward reaction will be favored and reaction shifts to the right. If K is less than Q, the reverse reaction is favored, shifting towards the left. One cool thing that I learned when I was learning this was that if you put K on the left side, and only if you put K on the left side, and Q on the right side, whatever side the arrow is pointing towards is the direction that the reaction will shift.
So let's take a look at the reaction that we're dealing with in this problem. We have carbon monoxide gas, which is readily oxidized at room temperature by diiodine pentoxide gas to form purple iodine gas and carbon dioxide gas. Notice that everything is in the gaseous phase. This is going to affect how we talk about equilibrium. So normally, when we talk about equilibrium, we're talking about Kc. C is for concentration, because we're talking about the concentrations of the reactants and the products. But in this case, since we're only talking about gases, we're going to talk about Kp. In this case, Kp can be written as the pressures of the products raised to their coefficients divided by the pressures of the reactants raised to their coefficients. So we have the pressure of iodine times the pressure carbon dioxide raised to the power of 5 over the pressure of carbon monoxide raised to the power of 5 times the pressure of diiodine pentoxide. So let's go ahead and start this problem. Part A. How does the yield change when the pressure increases? So the reaction is going to shift to reduce the total number of moles per unit volume. So because the number of moles are the same on both sides of the reaction, no change in equilibrium is going to occur. So we're just looking at the coefficients in the balanced equation. We have a 5, a 1, a 1, and another 5. So on the left side we have 6 things, and on the right side we have 6 things. So there's no way that this equation can go to one of the sides to reduce the number of moles per unit volume. So the answer to part A is that there's going to be no effect on the overall yield when the pressure increases. And so the answer to part B will be the same as the answer to part A. When we decrease the pressure of the system, there is also no effect on the overall yield of the reaction.
So how would the yield change from increasing the temperature? Changing the heat will actually change the equilibrium constant. If you remember from one of the earlier slides, KQ tells us the ratio of products to reactants for a given reaction. One other thing that needs to be added, though, is that this is for a given temperature, so changing the temperature will thus change the value of K. Since this is an endothermic reaction, then heat must be on the left side of the reaction equation, because heat is going into the system. Le Chatelier's principle tells us that if we add something to one side of the equation, it will cause the reaction to shift towards the other side in order to try to re-establish the equilibrium. This means that if we increase the heat, we're increasing the amount of reactants. If we put this into our equation to determine Q, we will add this to the denominator, which will decrease the value of Q, making K greater than Q. Shifting this reaction to the right and towards the products and increasing our yield.
Part D, how does the yield change when temperature decreases? This is just the opposite of Part C. If we decrease the temperature, we are reducing the heat, which is on the left side of the reaction and the bottom of our equation right here. So if we're making our denominator smaller, that means that we're making Q larger. So now we have the situation where Q is larger than K, which will force the reaction backwards or to the left, and this will decrease our yield.
The final part of the question asks, how would the yield change from decreasing the volume of the reaction vessel? Well, changing the volume is going to have a very similar effect on the system as changing the pressure did. When we decrease the volume of the reaction vessel, we are increasing the pressure because we now have the same number of moles in a smaller amount of space. So, the reaction is once again going to shift towards whichever side has less moles of product in order to counteract the stress. And once again, both sides have 6 moles total, so neither the forward nor the reverse reaction is favored. This will have no effect on the yield.
So just to recap, increasing the pressure will have no effect. Decreasing the pressure will also have no effect. Increasing the temperature will increase our yield. Decreasing the temperature will decrease our yield. And decreasing the volume of the reaction vessel will also have no effect.
Our exploration of gaseous equilibrium has now come to the end, so thank you so much for watching, and I hope you have a better understanding of how this works.